King of kings, salvation rings. Okay, so lesson 4. Is direct variation. Okay. So, direct variation is kind of a different take on looking at the slope, and slope is a rate of change. We've already heard that the slope is the slope is a rate of change, right? We've also seen that it's m. When we're talking about it with direct variation, we're going to give it a new name, and that is the constant of variation. I'm going to try just turning that down, and maybe when I upload this later, it won't be like copyright strike. Let's see. Because I'm going to put this on YouTube because it's the easiest place to put it for people to watch it later. And since there's music in the background, it might be like, that's copyrighted material. You can't make any money off of it. And then I'm like, joke's on you. I wasn't going to make money on it anyway because we have like 5 subscribers on that channel. So, whatever. So, constant of variation. So, when we write a direct variation formula, we usually do it like this. And that is y equals k times x. All right? So this right here is the constant of variation. Now you'll notice that this is just like our y equals mx plus b or whatever else we might see there. And it's also the slope. So if we have an example where we're trying a graph example where we're asked to find the constant of variation, we're really talking about the same thing as what we've been talking about. So if we have this example graph here, right, where this is the x-axis and this is the y-axis. And then let's say our graph looks something like this. Try to do something that is familiar with things that we've seen before. Okay. Where that's our picture. And the equation we might be given for this one could be y equals well, I didn't really draw that quite like I meant to. Let's see if I can make it a little bit better. Why are you Oh, because you're close. That's probably a little closer to what I was trying to draw. And that would be up 4 over 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so up. Oh, yeah, of course. That makes sense. Okay, so this is what I was trying to draw, more or less. That is y equals 1/2 x plus 4. Right? And we might have a problem that said, what is the constant of variation? It probably says something like the constant variation for the function, but in order to get enough for our notes, that's what we need. So, what would K be in this problem, ladies and gentlemen? 1/2. It would be 1/2. So that's really what we're talking about is just another name for slope. Makes sense so far? Easy peasy, lemon squeezy. Let's do a word problem. So, the distance, a jet plane, travels, varies directly as the number of hours it flies. A jet traveled 3,460 miles in 6 hours. Oops. Write an equation for the distance d flown in time t. All right. So this is the way we go about it. Now, the fact that this says the key phrase here in this problem is varies directly. Because it says that the distance varies directly as the number of hours, then we know that our equation, is going to be in the form y equals k times x, ultimately. Now they've given us some specific variables to use, so our variation of that formula is going to be d varies directly as t, right? So what we need to find out and we need to discover is what k is for this problem. That's our goal here. Right? So what we've been given is I didn't write a word, did I? I think I said it out loud, but then didn't type it. I think it's 6. Is that what I said? Is that what y'all wrote? In 6 hours. There we go. Now we have enough information to solve this problem. Okay, so what we can do is we can take and we can substitute these numbers in for d and t in order to solve for k. Right? So what we're going to do is we're going to take 3,460 and put it where the d is. And we're going to take 6 and put it where the t is. And then we're going to solve for k. So what would we do to solve for k here?
We would get the 6 on the other side.
How? You're right, but
you subtract 6.
Is that 6 added?
Oh, you would divide it off?
You would divide it because it's multiplied. So we're going to divide both sides by 6. So then K equals what number?
576.6666667.
It's not quite what's written there. Let me see whether. Oh, look. It's because I wrote. That's true. That's fine. We'll go with what I actually wrote instead of what's in the book. You're probably 100% right. Somebody else agree with?
I agree.
Okay, so say it again since I accidentally wrote down 300. I actually said 3,460 instead of 3,420. So what did we get as our K?
576.6666667.
So 576 and 2/3, or 576.7 repeating. And if we're rounding, 576.67 sounds great.
Do you care which one you do?
On a word problem, it would this is what we want. Almost certainly. On a regular not word problem, then I want either one of these, but I generally prefer the fraction because it's easier. Well, actually, that's debatable on this particular problem. But yeah, on a word problem, we want the rounded decimal. And if it's this should have been a pretty answer. But if this wasn't, then you would usually be able to tell what decimal to round by what either what the other numbers are rounded by in the problem, or because it says round to the nearest 10 or whatever else. So it should tell you where to round if that's going to be a thing. So now to write our equation, it would be D equals 576.67 T. That's our answer. Does that make sense?
Yes.
Good. Good. We are going to end up ending a fair bit early, and I'm going to give you some homework and let you get started on it. Because, like I said, I don't want to get too ahead because I don't want to finish this unit and then have to review for weeks and weeks to get us back to where we're taking the test. Wasting time. Better off doing it in chunks. So.
Can I finish my corrections on the test?
Probably so. OMG. Homework is on pages 185 through 187. And we're going to do numbers 10 through 42 evens. And you have time to get started on that or work on your corrections if you prefer. So there it is.